Okay, so these are the solutions to the ABC that the MA031 class did in class on Friday, and I'm going to start off with the first 9 questions here. Um, the first question is to add 2 rational expressions, and should have been fairly straightforward. You have different denominators. You need a common denominator to do that, and the common denominator will be x times x plus 1. And of course, that means this 1 is going to get multiplied by an x plus 1, and this 1 is going to get multiplied by an x, and then you combine those, get a 2x plus 1. So pretty straightforward, pretty easy. Could have been written with the distributed denominator of x squared plus x. Now, what is interesting is it's much more the place in calculus 2 or in differential equations that you would actually start with the 2x plus 1 over x squared plus x, say, and you want to break it apart into its 2 components before they were added, doing something called a partial fraction decomposition. So instead of adding and combining the 2 fractions, you're actually tearing the fraction apart and writing it as 2 separate entities, which is useful in integration of certain rational expressions, as I said, in either calculus 2 or in differential equations. Um, Number 2, very similar, again, adding 2 rational expressions, and shouldn't have been too difficult. Of course, denominators of y minus 2 and 3, your common denominator is going to be the product of those 2 denominators. Now, the numerator, of course, on the left-hand side just ends up being a 3y, because this term would have to be multiplied top and bottom by 3. And the fraction on the right is going to be multiplied top and bottom by y minus 2. Right? And in doing that, you're going to multiply the 2 binomials and then add on the 3y. And so when you're all done, you should have a y squared minus a 5y plus 12 as your numerator. And denominator, you could have left it in the factored form, or you could distribute that. Number 3, uh, got a variable in a denominator here. Probably a first step would be to think of this as 2t equals negative 4 by moving the 5 from the left-hand member to the right-hand member. And so t um, times the negative 4 gives us negative 4t. And solving that, we get t equals negative 2/4, which is okay, but really should be reduced to a negative 1/2. All right. They do ask that answers be in their lowest terms or in reduced form, so the proper answer would be negative 1/2. Did notice a few papers that had the negative 2/4 on it. Question number 4, another equation. You've got y over 2 minus 2 equals y over 3, and the answer should have been 12. Um, that gets done by doing y over 2 minus 2 equals y over 3, and so probably you think about getting the variables together on the same side of the equation. So you have y over 3 minus y over 2 equaling negative 2. Here you're going to need a common denominator, and that common denominator is going to be a 6. Pretty apparent there. And so that's going to make this a 2y, and it's going to make the minus y over 2, you're going to be multiplying top and bottom there by 3. And so going to have minus 3y. So 2y minus 3y is going to be negative 1y. So negative y ends up equaling negative 12 when we multiply the 6 to the other side. And so your answer for y itself would be positive 12. Okay. Good results for question number 5 with the absolute value inequality. The only thing I would mention there is if you're going to list your answer as r is less than or equal to minus 2, and r is greater than or equal to 6, um, you really should include the logical connector or there, right? Because you can't have a number that does both things. And just to write them without the logical connector doesn't make it really clear that you're expressing two different intervals. In fact, the interval notation might be the better way to do it. Um, so we're sort of looking for r is less than or equal to -2, logical connector, or r is greater than or equal to 6. Okay? Um, Values in either of those two intervals would work. Number 6, little sketch over here. We've got an x-intercept of -3, so it's going to go through there, and a y-intercept of -1, so it's going to go through here, right? So very apparent number 1, since they want slope-intercept form, they're talking about y equals mx plus b, all right? And they've out and out stated right here what your b value is. Your y-intercept is -1, so that's going to go in there. And then all that's left to determine is the slope. And since the line has an x-intercept of -3 and a y-intercept of -1, it's pretty easy to identify that the slope is negative. The rise is 1 and the run is -3 if you look at it from that point of view. The rise from -1 up to the x-axis is 1 unit, and then the run from the origin back to the x-intercept of -3 is at -3. So your slope would be -1/3. Should have been your answer there. Um, 7, they want to find the root, so they're looking for the value of x, and this could have been factored either by AC method, which we've discussed numerous times in lecture, and so you could have solved it that way. Perhaps just factoring it is no problem for you, whichever way you do that. And the two answers would be -3/5 and 4. And then we run into our trigonometric section, um, 8, 9, 10, 11, 12. And here they want the cosine of 3 pi over 2. Um, 3 pi over 2 is a rotation of 270 degrees. And hopefully you've got down how you're going to do your trig ratios. There's a variety of ways you could do it. It would correspond to a reference angle of 90 degrees in the third quadrant. And cosine of 90 degrees uh, should be determined to be 0. So your answer for cosine 3 pi over 2 is 0. And then the next exercise is a tangent of 11 pi over 6. And 11 pi over 6 is in the fourth quadrant, right? 12 pi over 6 would be a full rotation. So 11 pi over 6 is going to lie somewhere in the fourth quadrant, which means what? Which means tangent would be negative, right? 11 pi over 6 be in quadrant 4, and we know that tangent is negative in quadrant 4, so it's going to have a negative value, and it's going to correspond to the tangent of using a reference angle. The difference between 11 pi over 6 and 12 pi over 6 is pi over 6, or 1 pi over 6. And tangent of pi over 6 or tangent of 30 degrees, you should somehow be able to determine that that's 1 over the square root of 3. And of course, again, the negative because you're in the fourth quadrant. So one answer that would have been acceptable would be -1 over the square root of 3. Or if you chose to rationalize it, then it would have been negative square root of 3 over 3. So there's the first 9 questions. Um, we'll move on to the last question on this side, question number 10, and I'll get rid of this ink for you. Um, and the reference triangle that you're given there in number 10, they're looking for the length of the hypotenuse. And so with C as the unknown, the hypotenuse, and the angle provided here is pi over 4. That pi over 4 is supposed to represent an angle, not a side. And you know the opposite side, and you're looking for the hypotenuse right here. So that's going to be a sine ratio is one way to do this. So sine pi over 4 equals 2 over c would be one way you could do this. The sine of pi over 4 corresponds to the sine of 45 degrees if you're thinking in degrees, and the sine of 45 degrees is square root of 2 over 2 equals 2 over c, which gives us a proportion. And so c times the square root of 2 is equal to 4. Okay, so c is 4 divided by the square root of 2 is one way to do this. Now, from there, you probably would rationalize it. And in the process of rationalizing it by multiplying top and bottom by that radical square root of 2, we get 4 square root of 2 over a 2. And then since we have multiplication right here, 4 square root of 2 means 4 times the square root of 2. We can cancel um, and arrive at a final answer of 2 square root of 2. Now there's other answers that would be acceptable. Of course, 2 square root of 2 is equivalent to the square root of 8. Um, and of course, the answer we initially came out with of 4 over the square root of 2 would all be acceptable answers. Question number 11 is pretty straightforward, pretty easy. Sometimes these are more difficult. This number 11 didn't turn out to be. They want the sine ratio, and you should know the sine ratio is the ratio of the opposite over the hypotenuse. And since the angle theta they gave you was across from the side that was given as a 1, they gave you the opposite side, and they gave you the hypotenuse. And so the sine ratio would simply be 1/3. And that was as question number 11, trigonometry question, goes. That was a fairly straightforward, fairly easy question. The graphing, we're graphing from negative pi to pi, so you can sort of want to put in your reference points. So I'll put negative pi there, and I'd put pi over here. And since we're just graphing y equals sine x, our amplitude is going to be maxed out at 1. So I'm going to have 1 and minus 1 on my y scale. And then I'd want to identify pi over 2, and I'd want to identify negative pi over 2. And then typically the way these go is to have in your, at least in your mind's eye, an idea of what sine looks like. And so you identify the peaks and valleys of the curve, and we've got going through the origin, we've got going through pi over 2 and 1, and we've got going through pi and 0. And then in the negative side of the y-axis, negative side of the x-axis, you're going to go through negative pi over 2, negative 1, and you're going to go through negative pi 0. So you identify your highs and your lows, and then it's just a matter of smoothly trying to connect those high and low points and the midpoints um, as best you can. Um, by scaling your graph, you have identified uh, coordinates of minimums and maximums that they asked for right here. The pi over 2, 1 is obviously identified by the scale, and likewise with the negative pi over 2, negative 1, identifying a minimum point. So that's really all that's required there. 13, they want to simplify an exponential expression. They got 81 to the 5-force power, uh, 5-force exponent. Remember, the 5 is the power, and the 4 is the root. So if we were to use an old school notation on this, a radical notation, they're talking about the 4th root of 81, and then they're taking that 4th root of 81 and raising it to the 5th power, right? So 4th root of 81, if you think about it, some number times itself 4 times is supposed to result in an 81. And of course, 81 you probably know is 9 times 9, and each of those 9s can be broken into a 3. So your numeracy should kick in and realize that the 4th root of 81 is 3. So that thing's a 3. I'll just write over it. And then we're going to raise 3 to the 5th power, which merely means you're going to take your 81 and you're going to multiply it by another factor of 3. And so 81 times another factor of 3 should have given you a final answer of 243 for number 13. Um, Now, number 14, we've got the negative exponent involved, and we've got 1/2 to the fourth power. Probably the simplest way to look at this is leave the 1/2 to the fourth power alone. Leave that as it is. Use the 1 over rule on the 4 to the minus 2 power, and think of that as 1 over 4 squared, changing the sign of the exponent. And then 1/2 to the fourth power, this piece, 1/2 to the fourth power is 1/16. 1/2 times 1/2 times 1/2 times 1/2. It's going to be 4 2's in the denominator multiplied together. That's going to give you 16. And the 4 squared is in the denominator again. It's going to give you another 1/16. And then if you just multiply those two fractions, you're going to have 1 over 256. So the answer to number 14 should have been 1 over 256. And so that's questions 10 through 14. And we'll move ahead here and get the last bunch after we kick up our eraser here. Um, so these look to go pretty well. There was real improvement on this. And so this last bunch, not really too any more difficult. So we're moving into this last set. Um, This question 15 sometimes can be a common base question, sometimes not. Um, this particular one is the 9 and the 3 you should see as exponentially connected. And so you've got 3 squared to the t plus 2 power. And of course on the right hand side you just have 3 to the first. Remember to distribute this multiplication of exponents. When you raise a power to a power, you multiply the exponents. And so we've got 3 to the 2t plus 4 equals 3 to the first. And so now with a common base, we've obtained the common base. We know that 2t plus 4 has to equal 1. So 2t equals negative 3. And so t is negative 3/2. All right. So negative 3/2, negative 1.5, negative 1 5/10, if you want to read it that way. 16, also a common base exercise. 4 and 2 are exponentially connected. And so we've got 2 squared being the 4. And then that's being raised to the 3t power. And then on the right hand side, we have 2 to the first power again. And so that gives us 2 to the 6t equals 2 to the first. And again, the common base, so the exponents have to be equal. And so you should have ended up with an answer of 1/6 on that problem. And then on to the graphing question. Okay, the thing about the graphing questions is you want to get a good scale. You want a rendering that represents the situation, so you have a workable diagram for when you're doing those calculus problems. This, of course, is a linear equation, and we're going to have a y-intercept of 0 and an x-intercept also, of course, of 0. It goes through the origin. Um, we have a slope of negative 1/2. So in terms of scaling that, it doesn't do me an awful lot of good, but um, a slope of negative 1/2 means a rise of 1 and a run of negative 2. The line is going to run left to right downhill. So I'd probably map out something like this. So that would be like negative 2. And you don't have to label every point as long as your scale can be determined. I'd call that a 2 there. And then trying to be consistent, this would be negative 1 here, and this would be positive 1 here. Now again, the in a calculus question, there might be more attributes available that you need to plug into the problem to get a good picture. But from what they're telling me here, I know it goes through the origin. I know it has a slope of -1/2. So if I rise 1 and run -2, I know it's going to go through this point over here. It's going to go through -2, 1. And likewise, it's going to go through +2, -1. So then, um, without a straight edge here, just trying to connect these, not doing a great job. This would be your line in here, right? And a little more difficult to do this on a tablet than it is probably in real space, so I apologize for that. We are also supposed to identify intercepts and that sort of thing. Well, we've pretty clearly identified that the y-intercept is 0. It goes through the point 0, 0. The slope should be identified. They want to know that you know that slope is -1/2. So you can either write it to the side like that, and not a bad idea probably to label the equation y equals -1/2 x, something like that. 18, when you got done with this is a parabola, of course. Pretty apparent that this goes through 0, 0, because if x is 0, then y is 0. Your constant, right? If we're thinking y equals, generally y equals ax squared plus bx plus c. The c value is your y-intercept, just the same as it is with a line. And so in this case, we know our y-intercept is 0. If we go ahead and identify the other zeros by taking the equation and setting it equal to 0, it's fairly apparent the other x-intercept is going to be 5. So I would probably space this out. 1, 2, 3, 4, 5. And there's my other x-intercept, my other root, if you will. And then with a root of 0 and a root of 5, the axis of symmetry for this parabola is pretty obvious. The axis of symmetry is going to be x equals 2.5, 2 and 5 tenths. And if x is 2 and 5 tenths, and you replace the x by 2 and 5 tenths, um, you get a fairly easy computation. 2 and 5 tenths squared is 6 1/4 minus 12 1/2. And 6 1/4 minus 12 1/2 gives me -6 1/4. So that remember is a y value that we're obtaining. So I took the axis of symmetry, which I've identified right there, as 2.5, which is going to be right between 2 and 3, right? And I've determined that the vertex, that the turning point is going to be at 2 and 5 tenths, -6 1/4. So you want to note that because they're asking for vertexes and things like that. Now there's the parabola on the one side, and here's the parabola on the other side. We've identified the zeros at 0 and at 5. We've identified the turning point, and we've identified the axis of symmetry right here. We just put that on there. Um, and then you'd be all set to do any kind of calculus with that you needed to do. The last two, 19, not too bad. We've got the area of a triangle, which has a base of 8 miles and a height of 4 miles. So we got an 8 here, we got a 4 there, and of course you know the area of a triangle is base times height divided by 2, or 1/2 base times height. So we're going to do the 8 times the 4, get 32, divide by 2, and get 16. But also remember that we need units on this, and since this is area, it's square miles or miles squared, whichever way you want to write it. And then lastly, number 20, right? Here's the kind of shape they're talking about a can, right circular cylinder, right? And they're telling you that this can has a height of 5 units, and they also give us the radius of 5 units. And you always want to watch on these questions to see if they're giving you radius or diameter or something like that. The formula for the volume is basically a circle. The cross section is a circle, right? The top of the can, the bottom of the can is a circle, and then that circle has height. So it's like a whole bunch of DVDs stacked on top of each other. And so we have pi times 5 squared times 5. And so that basically ends up being 5 cubed. We can leave our answer in terms of pi. And so I got 125 pi. And those are centimeters cubed. Okay. And you always want to include your units. So those are the solutions to the ABC test that you had on Friday. If you have more questions about it, we can answer those on Monday. And as I mentioned in the announcement on the WebAssign page, if you weren't able to get in there, I'd like you to go to YouTube and do a search of partial fraction decompositions. Partial fraction decomposition. And it's just a method for, as I said, tearing apart fractions. Normally, what you've experienced to this point is adding rational expressions and combining them into a single rational expression. Um, Instead, what we're going to be talking about for preparation basically for calculus 2 and for differential equations is taking a given rational expression and breaking it out into separate fractions, because that will make it easier to do some of the processes that you need for calculus 2 and for differential equations. So we'll see you on Monday, and as I said, if you have questions, we can answer those then.